Hi, I'm John McDonald from Valve, like you said. This is the Vulkan panel. It is a retrospective on the life and times of Leonard Nimoy. Hopefully you're in the right room. I'm just kidding, of course. It's about the graphics API. First, I wanted to start out with a little introduction. We're going to basically talk about what we hope you take away from the panel today. We'll talk a little bit about why we're talking about Vulkan, and and I'll introduce everybody with a little bit more detail, and then we'll get going from there. So I'm hoping that with this session, or we're hoping that with this session, you guys have a clear understanding, basically, of the costs and benefits of implementing Vulkan for yourselves, or taking advantage of it, and kind of have a rough idea of like where Vulkan is right now and where it's moving forward, where it's going to be moving forward. And we're kind of talking about this because at the previous Steam Dev Days, we talked a lot about OpenGL, and then we talked to a lot of you about OpenGL, and we got a lot of feedback that OpenGL has some benefits, but it has a lot of drawbacks as well, and that's that's not untrue. So we got together with members of the Kronos group, and we pushed forward this API that was hopefully a clean slate and really solved a lot of those drawbacks, but still had all of the benefits. And we're talking about it at Steam Dev Days because we've found that basically having an open API that we've really tried to push as many of the pieces as possible to be open really helps make everything better for all of us as we're making games for our customers and we're serving our needs. So let's go ahead and jump into who we're actually talking to. I have notes. I had to write them down because there's too much stuff to make sure to remember. So on the end here, we have Jeff Bolz. He's a distinguished engineer from NVIDIA, and he's also representing the sort of hardware members of the Vulkan working group today. Vulkan was, of course, it was a collaborative effort among basically everyone, hardware and software vendors alike. But Jeff, during 1.0's sort of bring up, was unique, that he closed more issues than anyone else. He distinguished himself in that manner. And so it's probably safe to say that Jeff has more Vulkan in his head than anyone else on Earth. So we're really happy that he's here with us. And then next to Jeff, we have Dan from Valve. Dan and I were sort of the two primary folks from Valve, although there were other folks as well, helping work in the working group to shape Vulkan 1.0. And then Dan was the first developer to actually implement Vulkan in an application with Dota 2 way, way before release with drivers that barely worked. And it was and a spec that was still very much in flight. So I'm really glad that he could join us today. Next up is Alen from Croteam. Oh, why don't you guys, I should have done this. Alen, why don't you wave so that, can you wave at the crowd? Thank you. Alen, so Alen's one of the early adopters of Vulkan as well at Croteam. And the Talos principle implemented Vulkan, also while the API was still in development. And the public version of the Talos principle that's available on Steam has supported Vulkan from the first day of its release, which we're really happy about. It was really cool to see somebody who wasn't super deeply involved be able to adopt and demonstrate that, hey, this thing that we all think works. So that was really great. Next, we have Mikko from Unity. Mikko currently leads the, could you wave at the crowd, please? Thank you. Mikko leads the Vulkan team at Unity and has also basically done the backends for OpenGL and OpenGL there. So he's got quite a lot of experience. And then finally here is Rolando. Rolando is visiting us from Epic, and Rolando started coding when he was 11, which is even earlier than me. And he's been at Epic for 4 years, which is pretty rad. He's basically responsible for all of the Vulkan code in UE4, so if it works, it's his fault, and if it doesn't work, it's also his fault. He is also a member of the Kronos working group, and he helped ship Protostar, which was the first Vulkan demo running on Android on UE4 for the Samsung S7. And there's a joke in there somewhere, I know, but I'm gonna just let it go. So that is everyone on the panel, and I will try and slow down my speech a little bit because I know I'm talking too fast. But so let's go ahead and get started with a question for just everyone, and we will purely capriciously start with Jeff because it's easy for me to remember. What was the sort of goal that you guys were hoping to achieve with like Vulkan? What was it you were hoping to get out of it?
Yeah, I mean, it was nice to be able to have a clean design without some of the legacy burden of OpenGL, and you know, there are other APIs in the world, but it's nice to have one that all of the IHVs and ISVs work together on collaboratively, and that can be supported on every platform and isn't tied to, you know, OS versions or anything like that. So from our point of view, you know, we want Vulkan to be everywhere. We support it on all of our platforms, and we're very optimistic about the future of it.
Great. Dan, what about you?
So as John mentioned, we've been involved with Vulkan kind of since its very inception, and our goal with implementing Vulkan support in Source 2 was, of course, the usual reasons of wanting to have a high-performance rendering backend that worked across multiple platforms. But also, we wanted to make sure that the API was something that was going to be usable and efficient for other developers. So by sort of using Source 2 as a testbed, we could, as Vulkan was being developed, try out different API designs and find out what worked and what didn't. So it serves kind of as a testbed to find out how to make Vulkan most efficient.
Alen, at Croteam, what were you guys hoping to get out of Vulkan?
Well, for years we've been noticing more and more discrepancies between what the hardware can do and what we can actually use through the existing APIs. And Vulkan was a really nice chance to be able to access the hardware at the lower level, get better performance, get more features. And additional bonus was that it offered more, all of those things across more hardware vendors at the same time, and also both for the mobile platforms and for the desktop and for different OSs. So it's a very nice proposition going forward, and we hope that it will allow us to target more platforms more easily with more performance and features.
Great. Mikko, if all of the good answers have not been exhausted, what were you guys hoping to get out of Vulkan at Unity?
Yeah, for us it's mostly been so far just the benefit of being able to have like a clean new start for a low-level graphics API, especially on mobiles where the driver quality on GLES various versions has been quite, well, interesting, let's put it that way. And this allows us to...
That's very politic of you.
Yes. So this allows us to have a more control over what actually is happening with the hardware, so we get to do more things that we want to do, so that driver doesn't get to our way.
Great, great. Rolando?
So basically, after working on 10 years on consoles and then switching to PC, we saw that we didn't have the gains we wanted on performance. And then I worked on Metal, and that was very great as far as getting lower, closer to the hardware and having more control. Then Vulkan came out with PC and Android and Linux. So it was like, there's no question, that's what we want to use.
Great, thanks. All right, so with that in mind, let's kind of take another sort of stab and talk. Where your implementations actually live now? Like, have they shipped to customers? Are they still in internal development? And this time we'll start with you, Rolando.
So right now in UE4, for 4.14, which is our next release next month, we'll have full, we already have the mobile support in, so we shipped that back with the ProStar demo. We had to go in and make it work very well with the desktops. So we have part of our defer rendering running on it. We don't have the full Shader Model 5 with compute shaders working yet, but basically our goal is to get there and get Paragon, our game, and our old games running on it.
Cool. Mikko?
Yeah, so we released an experimental build with Vulkan support of Unity at the end of September. So you can go and get it from our website. You can find the link from our blog. And we're planning to ship Vulkan properly in Unity 5.6. And we are currently fully feature complete and at the same feature parity as DX11 and other high level renderers.
Great. Great. Alen, I know the answer, but let's say it again anyways. Where is the status of your Vulkan implementation?
So we've shipped Vulkan with full feature parity to other APIs, both on Windows and on Linux and on Android. We're seeing very nice results on all three. But there's going to be talk more later, I suppose, so I'm not going to steal from that question. But the only reason why it's not really the default app right now is because there's still some corner cases where there might be some crashes or some issues with drivers. But in 99% cases, this is really, if you want to tweak with the game, that would be the preferred API for all platforms.
Awesome. Great. Dan, what about our status? I don't actually know.
All right. So Dota 2 is our first title that ran on the Source 2 engine, and back in May we shipped Vulkan support as downloadable content that's free on Windows and Linux. So that's been shipping to customers for about 5 months. And then other efforts at Valve, we have the Steam overlay working in Vulkan, both on Windows and Linux. And right now we're working on Steam VR on Vulkan on Windows and Linux.
Cool. And Jeff, last but not least, I think we know, but
yeah, I think most people realize that NVIDIA has been shipping a Vulkan driver since day one, and that's on Windows, Linux, and Android. Though I would say that I think that the quality of the driver has improved over the last 6 months. Having several real games or game engines out there and reporting bugs has certainly been helpful. You know, and bringing up Doom in particular flushed out a lot of stability issues, and so I'm very happy with how the driver is now.
Great. Okay, next I'm going to ask a question here for Mikko and Rolando specifically. So compared to the other APIs that you've worked with or on, like how much sort of your time are you finding that you're having to spend dealing with bugs that are specifically like Vulkan bugs, rather than, oh, these are higher level renderer bugs, or they're bugs, you know, the driver bugs, these types of issues? How is that working out for you? And I guess let's start with Rolando this time.
It's been interesting. As Jeff said, in the last few months, they've been pretty great, all the drivers on all the IHVs. One of the problems is on mobile because of the problem of installing basically updates for the drivers, the carriers involved and all that. But I think right now it's a very good spot. Like people jumping in right now have a huge advantage over people that started 6 months ago.
Thank you for being an early adopter. We appreciate it. Mikko, what about you?
Yes, well, compared to, for example, when we started working on GLES version 3, when that came out, back then the biggest problem was the driver quality of those early drivers. Of course, you guys took the biggest burn with the Vulkan driver quality earlier on, but for us it's been surprisingly easy bug-wise, not only because the debugging tools like RenderDoc supported Vulkan really quite early on, so it's been a tremendous help for us. And also the validation layers have been really good for us. And also we've been working closely with all the hardware manufacturers, plus the guys who actually work with those layers, so that's been really helpful.
Great. I guess this is actually a super related question. I did not actually intend for it to be, but Alen and Dan, like, how have your experiences been with drivers in Vulkan? Sort of, I guess I should ask recently, because I know Dan and I dealt with drivers that were open source drivers written for hardware where we traced down kernel mode bugs, which was a very interesting experience. But sort of since release, how's your experience been with drivers compared to the other APIs you worked with?
I'd say in general it's been excellent. I mean, we've shipped on NVIDIA, AMD, Intel's proprietary driver, as well as on their Mesa open source driver on Linux. And recently, AMD's brought up an open source driver called RoutV, and it's running there as well. I think we see a lot less bugs with the sorts of things we did in OpenGL. Like, for example, we would run into a lot of discrepancies between GLSL parsers and different drivers, and because Vulkan has moved to this binary representation SpearV, it's kind of reduced the amount of bugs. But you know, we've been in a little bit of a special position because we worked with all the IHVs during the development of Vulkan. So you know, we definitely encountered a lot of bugs before Vulkan shipped, but since then, the driver quality's been great.
Now, Alan, you mentioned that you guys had some driver problems in sort of 1-ish% of cases. Do you want to maybe expand on that a little bit?
Well, there always are bugs in drivers, whenever you want to try implement some new features, there's going to be some corner case in some device. But overall, I'd say that Vulkan drivers are, on average, more stable than OpenGL drivers specifically, even DirectX drivers, and that it feels, it's not very scientific to say that, but it feels like it's easier to get through, to get the IHVs, to see what it is, and to fix it, because everything feels much lightweighter in Vulkan. And most of the, as the first steps have been taken and all the drivers have been improving, the remaining things that we see mostly on desktop are more in the other areas, like for example on Linux, the biggest problems right now are for some cases where the game starts in OpenGL, we want to switch from OpenGL to Vulkan, and then there's something in the window manager, something that crashes because of this change in the API, but it's not in the Vulkan itself. So we would say that on average it has less problems with the drivers, especially considering that this is so early. If it was like a new version of OpenGL, I would expect much more problems.
So Jeff, Alan actually brings up an interesting point. One of the promises of Vulkan was that we would have sort of lighter weight drivers. Is that actually like a thing that we really have? Like, are the drivers simpler than OpenGL drivers, which I didn't mention, but you have worked on a lot?
Yeah, I would say that the actual part of the driver that's specific to Vulkan is much smaller than OpenGL. So in our implementation, the Vulkan driver is in the same DLL as the OpenGL driver. And we did that in part because we want to share code having to do with compiling programs and allocating memory and how we set up to talk to the hardware and all that stuff that doesn't care about what API it is. So with all of that already existing, the actual amount of code that's there just for connecting the API to the hardware commands is actually pretty small. It's simpler than the corresponding OpenGL code, and so yeah, I think the answer is yes. It has delivered on that promise.
So just as a sort of random thought, like what is actually, we kind of talked about this a little bit last night, but you weren't there. So I will just throw you under the bus now. What is actually the sort of most complicated part of the driver for Vulkan specifically?
I think that probably depends on which hardware vendor you ask.
Of course.
Yeah, for us, memory allocation has been the sore spot, and that's just the way that Vulkan allows binding arbitrary buffers and images with whatever format to memory is not really how our hardware expected to be used, and so it's not a good fit. But we deal with it, and that's our challenge, and I'm sure other IHVs have different challenges, but that's
sure.
The nature of compromise, right?
Sure.
So yeah, but that's the main issue, and I think we've mostly dealt with it, and it's not going to be like a continuous burden. And future hardware will improve to better match. And this is something that affects D3D12 as well, so it's not unique to Vulkan. And so the hardware will catch up, and it won't be a problem in the long run.
So as a sort of related question, and I'll just purely capriciously start with Alan this time. When you were implementing Vulkan in the Talos principle, like what did you find to be the most technically meaty, sort of hardest thing to work with in Vulkan? Like, where did you find, oh, this is the thing I'm having to spend a lot of time thinking about and implementing or rewriting to sort of get things to a state you were happy with?
Well, of course, first there was a lot of issues because we were working towards a moving target before it was released. But if we abstract that away, again, same as Jeff said, memory allocation is an issue because it is complicated in various ways because of what the OS also dictates and as well the alignment issues and different things in there. But once you get through the basics of just what is actually required, because it's hard to grasp all of that, it's not actually that big of a problem in the end. But synchronization is probably something that, because it's now all on the back of developers, but that's a good thing because we now have complete control over it. But it's a thing that you have to be very careful about. Thankfully, the validation layers have improved much over time, which helps a lot Which when we first started working on that, there were a lot of cases that were not covered in validation layers, so you would just render something and it would render wrong, and then would you bang your head against which resource I didn't synchronize. But those would be probably the two most important things.
Great. I want to come back to that in a little bit, the validation layer and the test suite. But I will first sort of move on. Mikko, what about you guys? What did you find was the sort of most technically challenging problem that you had to deal with for adopting Vulkan?
Well, I guess it's, again, the memory management things, which we ended up trying multiple different approaches. And in the end, we just recycle all the objects, all the buffers, all the, well, not images because they are not that often reused, but mostly buffers, so that we try to allocate as little as seldom that we can.
So when you two talk about memory allocation, do you mean specifically that the problem is it because of the multi-threading? Is it because memory management is just, like you're certainly required to do more in Vulkan than you were in previous APIs. Is it the binding of the two? Is it dealing with when resources get freed? Like what could you maybe explain, either or both of you, could you maybe explain a little bit more what you mean?
Well, I guess it was mostly our own assumption in the beginning that once you have your own memory block and manage within that memory block yourself, creating a buffer would be, maybe say a buffer into that into some area of that would be effectively free operation to do, and it's totally not that. And then once we realized that we really don't want to do any of that stuff during the frame, we just got rid of it, and then everything got a good bit faster.
Great.
The main issue for us was because of there are a couple of different requirements. It's not just alignment, but those are kind of like block size sharing. For example, for some cases, you can have some objects in a particular alignment, but you cannot share memory block sizes that are. So the block, hard to explain. There's a block of a size bigger than alignment, and you must make sure that there's no two objects of different types within the same block and all this. So just to wrap your head around what the allocator actually must take care of, that's complicated. Yeah.
And Jeff, I assume these are because there is some hardware that exists that has these actual requirements, like no two objects of different types in the same block, right? This is one of the trade-offs that we consciously made for Vulkan.
Yeah, that's accurate.
I mean, it sounds more scary than it is once you just, because there was no API before they required that, so it was just some of those things you don't really read through the specifications letter by letter when you implement. You just implement something that you think seems reasonable, and then why it doesn't work, right? So and then you have to recode the allocator when you figure out all those details.
I see. Rolando, backing up a step, like what did you guys find? Was it also memory management?
Memory management was okay, I think, for us at the beginning. I mean, for when we shipped the Android demo, we basically did the most naive way you can do. Basically, one allocation per object and just get it done. That's part of our long rewrite to get it all working fine. I think for us, still the problem is all the transitions and memory barriers and image barriers. Because that's something you'd have to change the high level, but we can talk about that then later question, I guess.
No, sure. Dan, I have some insight into this, but what did we find was the most technically challenging problem?
Yeah, so memory management and image layout transitions probably would have been my top two answers if they haven't already been said. But the other one that's pretty complicated to get your head around is descriptor sets. So descriptors are basically how you bind your samplers, your textures, and uniforms into the pipeline state objects. And you have to manage your own descriptor pools, figure out how you want to allocate from them on multiple threads, and sort of how to optimize that and how to do it efficiently was pretty challenging.
Cool. Alen, you mentioned the validation layers as being really helpful during development, but you made an important point at dinner last night. We were talking about Mikko had run into a problem during their bring up, which I don't want to go super into the details of, but they were doing something that was surprising to one of the hardware vendors, and was like, I'm pretty sure that this is allowed, and Alen said, you said something about, well, we should add this to the validation layer.
That was actually wrong. It should be added to the tests, right?
That's right. But I was thinking about that, and I was like, that's really great, right? Because they're both open source. Like, we could easily contribute, and they have. Your experience has been that they have been getting better over time.
Yeah, but so our experience is that what's very interesting that when you implementing something new and you hit a problem, usually it's either a problem on your side or it's a problem on the driver's side. That's aside from the cases where there's an actual error reported. So in ideal case, we as developers would like errors to be reported for everything that you do that's not allowed. So error can be on the either on the API side or on the driver side or on the application side. If it's on the application side, then the validation layer should put it out. If it's on the driver side, then there should be a test in the test suite that the driver has to pass before being released. So the good approach when developing something for Vulkan, if you hit some of those problems, is to request a patch on either the validation layers or on the test suite.
Cool.
Can I add? Yeah,
Please.
definitely use validation layers. There's no way you can develop in Vulkan without them, especially now that they're way more mature than when it started. They're more lightweight, and they give a lot more detailed info, so you just have to have them.
Okay, great.
And well, there's actually we ran into one of our own bugs that only reproduced when the layers were not in use, which was fun. But it turns out it was because the layers always allocate all of the buffer IDs and image IDs monotonically growing, so they are never reused, whereas the driver itself actually does that. So if your caches are not properly scrubbed when you delete a buffer or an image, well, you're screwed.
That is an impressive bug. Jeff, what do you perceive? We'll start with you. What do you perceive as the sort of most important direction for Vulkan to moving forward?
Well, in the short term, so the Vulkan working group is working on Vulkan Next, and it includes a set of features for VR, and that includes something similar to OVR multi-view from OpenGLES. It includes some features aimed at making it easier or more efficient to write a compositor. So I think those are really important things that we're doing now, and I think we're solving the right problem at the right time, basically. In the more distant future, I don't know, but I'm very excited about the VR stuff that's coming up.
Cool. Switching gears a little bit to talk about a less technical but definitely still super important problem. And I'll start with the application vendors, but maybe you guys can think about this a little bit as well. What did you do to deal with your existing shader content? Like, I imagine you did not want to rewrite everything. That would be terrible. And we'll start with Dan this time.
Sure. So at Steam Dev Days, the last one, I gave a talk about how we get our shaders from HLSL to GLSL, and sort of briefly, we have our own lightweight translator and a system of macros to get from HLSL to GLSL. Because we already had a functioning OpenGL renderer in Source 2, there wasn't much additional work we had to do to get it into Vulkan. We were already using GLSlang, which is the open source reference implementation, and also the official Chronos tool for generating SpearV. So there was some slight modifications to the GLSL around descriptor sets and differences in clip space, but basically the shaders were identical going to Vulkan. Going forward, we've been working a lot with John Kesenich at Google and Lunargy on an HLSL front end to generate SpearV. So Contained within the GL Slang open source project in the master branch is an HLSL front end. The SteamVR that we're showing, Pierre-Loup has worked with getting all of our SteamVR shaders parsing through the HLSL front end and generating SpearV, and it's rendering correctly. Just last week, I hooked that up to Source 2. We're still working through a few issues, but ultimately, we plan to get rid of our own HLSL to GLSL translation and directly use HLSL front end of GL Slang to generate SpearV for Vulkan.
So you'll just be able to just pass your existing shader stuff through, our existing shader stuff through. I don't really work on Source 2, so.
The goal is to have the shaders be unmodified, and I know that's been the case with SteamVR, that the exact same shaders that were used for DX11 are used in Vulkan.
Great. Alen, now as an early adopter, your story is not going to be so magical, but.
Well, I have to disappoint you, but I don't really have much to add to what Dan said. It's really, because we had OpenGL support, there was really not that much of change. Most issues we had are just getting GLSL to Slang, GLSL to SpearV compiler to compile into our code base to interface with it, just because of the because of how it's structured, yeah. There's, because we support some platforms that don't support the latest C++ standards and stuff.
Are you saying that the problem may be that GL Slang is written by compiler writers?
Something like that,
okay,
yes.
Okay. That's fine. John K. is a
Yeah.
brilliant man, but he is a compiler writer.
Yeah, so those are just funny problems to have. Those are very simple to solve, yeah. But so it was very smooth.
Great. Rolando, did you have any?
So on Unreal, basically, we author all the shaders in HLSL. The material editor, you can write your own, add your own notes, and do, it will just generate HLSL. So we have, back in 2012, I think, that's when we added the Mesa shader compiler to basically process the HLSL and generate IR, which then we have a backend for GLSL, one for Metal, and now one for Vulkan. We are actually still generating GLSL, a little nicer GLSL than the normal OpenGL backend, and then we run it through GLSL Slang to get SpearV. We could generate SpearV, but we do get or use directly the HLSL front end, but we do generate some metadata from our cross compiler with the Mesa IR. So I still don't know if we're going to go that way, but that wasn't that hard for us to get it working because of this existing system we had.
Mikko?
Yeah, so we truly have a shader compilation pipeline, because all of our shaders are in HLSL originally, and then they go through our internal shader compiler that generates all the variants that are needed based on the keywords. That goes through Microsoft's D3D compiler, the actual DLL, even on Macs. We do things that it works. Then that resulting bytecode is translated into GLSL using HLSL-CC.
That's the tool written by Aras, is that right?
No, that's the James Jones is originally written.
I see.
I pretty much have rewritten all of that by now, again. But we use that also for generating Metal language, shader language. So that generates, for us, in this case, GLSL. That then goes to GL Slang. And with GL Slang, we integrate our hooks for getting the reflection data that we need for the shaders. And then that goes to the small v compressor, so that the shaders aren't that huge that they tend to be with SpearV. And then that goes to the actual game executable package.
Yeah, I think I saw, I think this is a thing I saw Aras talk about a little bit, that one of the problems with SpearV is because of the monotonically increasing sort of number that makes it hard for compressors, but it sounds like you guys have worked around that.
Yeah, that helped a good bit, but they are still very, very large compared to basically everything else.
Yeah, I think we talked about this early on. It was a sort of a trade-off between, we felt like we could always make it smaller later, but we couldn't, it would be harder to make it more expressive later. But it seems like maybe it's a reasonable thing to revisit. Yes,
this is actually, when we were trying originally to get our graphics test suite to run on Android, which contains like a few hundred test scenes with fairly lightweight shaders, but the shaders nevertheless. We kept running out of memory on Android handsets because of the size of the SpearV shaders themselves because we decompress them as a one large blob, so it becomes huge in memory. We actually helped in that a good bit, and we did some other tricks, so we only decompress the bits that we actually need.
I see. Let's talk about, obviously you guys all had existing render front ends for the other APIs that you already supported. But Vulkan has a few constructs that are actually uniquely Vulkan. So I'm wondering if any of you actually wound up making API level changes to your sort of render front end, and if they got you some things like that you were surprised by, or maybe you haven't made any yet, but you've got some sort of in the works. And Rolando, why don't we start with you?
Sure. Yeah, we definitely need. So the initial implementation we had a few months ago was a naive implementation and it wasn't very good for getting all the advantages basically on render passes and resource transitions and memory. So we're slowly changing the render to expose those concepts like transitions in memory of resources and render pass especially. Once we have that, then I think that's where we'll see the biggest gains in CPU and also exposes more of how the GPU works to the renderer itself. Because the renderer basically for us has to work with, but pretty much like Unity has to work with every other API. So it's hard for us to make a Vulkan-specific decision in the high-level render because we would either the support cost is high or would break other APIs. So we have to think very carefully what things we want to expose at the high level that would take advantage on all platforms, basically.
And I guess I should have asked this as well. What sort of your current front end, what does it sort of roughly look like? Does it look GL-like? Does it look
It looks
3D-like?
D3D 11-ish, and we added, so we already have in place the resource transition API, and our next big thing is PSOs, exposing actual pipeline state objects to the high level, and that'll help for both D3, 12, and Vulkan, and then render passes.
Great. Mikko, same question, but let's start with what your sort of rendering abstraction looks like, and then we can talk about the sort of other part of the question.
Right. So because of the fact that we still have to support both DX9 on desktop and OpenGLES 2 on mobiles, our rendering abstraction API still looks pretty much like a DX9 era abstraction layer, but underneath that, we already had most of that stuff you talked about had already implemented for GLES, so that we could take advantage of things like discarding a frame buffer and so on. So it was fairly easy for us to do. Well, it still involved a lot of code, but we pretty much knew what we had to do from the get-go. So that was kind of easy for us.
Alen, did you guys wind up making any changes to your renderer?
We're still looking forward to it. We are working on it a bit. So the same thing. We like to say that our current Vulkan implementation is actually practically DirectX 11 on top of Vulkan wrapper, right? Because the higher-level engine is supposed to interface with OpenGL, OpenGLES, DirectX 11, DirectX 9, and other APIs that were very similar in that respect, that they were state-based, and everything on a mid-level, our interface is still state-based. So as the first implementation, especially because it was a moving target at the beginning, we just decided just make it work. So we just wrap that, so caching all the PSOs on the fly, caching everything on the fly, and it's interesting that with that, we have, like, for example, on Android, there's huge performance boost. It says something about the thickness of the drivers and complications that adds in the overhead. On Linux, there's a huge performance boost over OpenGL. And what's interesting that on some devices, even on DirectX 11 is becoming a little bit slower than Vulkan on Windows. So this is with practically none of our optimization. We do have some support for rendering passes and discards and stuff, but there's a huge amount of work still in front of us, which I look more like as an opportunity, and a huge opportunity for optimization. So right now working on a native multi-threaded renderer for Vulkan, which would record commands on multiple threads, it's quite an undertaking.
So right now you're seeing performance gains, even though right now you are using Vulkan in a purely single-threaded manner. Is that correct?
We do have multi-thread renderer, but in the same way that it works on DirectX 11,
DirectX 11.
which just we record commands in our own format in other threads and then replay on the main thread. And there's still, so all the performance gain, they're small, but they're visible just in the driver overhead. The next steps are doing the native multi-thread renderer and then caching the PSOs.
Great.
We are actually seeing the exact same things that even when running in single renderer thread, which is like, yeah, the same thing, client worker thing, we are, especially when doing lots of draws and in cases where we would normally have lots of driver overhead, we are actually faster than the X11. And on Android, it's like completely blows GLES 3 out of water, even in single thread. And we also have this running in multiple jobs. And, well, the scaling is exactly what you'd expect there, yeah. It helps even more.
Great. Dan, I have some of these that we've talked about, but I will ask you, I think more, what do we have planned rather than what have we done?
Yeah, so we're sort of in the same situation of having a DX11-like abstraction in our engine, and the things we're planning on doing to improve that, number one, is to expose render passes through our abstraction. We kind of have all of the information to build up a render pass in our engine. It's just not passed down into our rendering layer right now. So that will help, especially if we ever, target a tile-based render. But even on immediate mode renderers, there's GPU gains to be had from using, for example, subpasses and render passes. Another thing is we want to make descriptors and descriptor sets sort of a first-class object in the abstraction, so that the engine can bake those up front if it knows that the bindings of an object are static. Because one of our biggest performance issues right now is updating descriptors. And what was the other one? I don't know, I'm blanking on it. But so I would say this too: if I was a developer starting from scratch, I would advise making your abstraction look like Vulkan, because that is pretty clearly the direction that APIs are going. Like if you look at DX12 or Metal, there's a lot of similarities between them. And to really benefit the most, your engine needs to look like that. And then you can support those features on the older APIs by emulating them.
Or by ignoring them in some cases too, right?
Yeah, although, depending on the variety of platforms you need to support, or the variety of, if we still have to support DX9 for XP reasons or something like that, you still do need those.
Certainly, I would expect, and Jeff can correct me if I'm wrong, I would expect hardware vendors would be happy for us to think about things in terms of like, how often am I changing render targets? So making render passes a first class citizen, even when you're targeting DX9 or DX11, would bring that to the forefront with that.
Yeah, absolutely. And I don't think, I think if an engine was structured that way, I don't think it would penalize the DX9 path at all. I think it's just a matter of effort to rewrite things to be that way. I did want to reply to what they were saying about the CPU limit performance. I'm really happy that that you're seeing all these improvements in CPU limitedness, and it's been without the kind of back and forth that we usually have between drivers and applications that we have to do for OpenGL. Whenever a new OpenGL game comes out, almost always we have to look at the API stream and try to figure out where time is being spent, and either do some optimization in the driver or give some feedback to the developer and say, don't do this. But we really haven't had to do that with Vulkan, and you guys are saying that it's faster anyways. So great.
So related to that, are you guys finding that you're able to identify like with just timers where your time is being spent when you make Vulkan calls? Like that's historically a problem in D3D and GL, that you wrap the API call and really you've just figured out how long it takes to marshal some data. In Vulkan, are you finding that you can actually measure the performance of, oh, I did this call and that thing turned out to be expensive?
Yeah, pretty much. Now you know where the time is going. Before you would call GL draw, and it could take milliseconds, it could take microseconds, who knows. Now you really know where the time is going.
Great.
Yeah, and you can just hook into any normal profiler you'd normally use, and the performance is stable. Otherwise, you could, in some cases, you'd see spike because some buffer gets full in OpenGL, so it actually does the submit middle of something, just because that's how it worked. and so now when we are building the command buffers, we can exactly see what's the actual CPU cost of building all of this stuff.
Great.
Yeah, but I've also been told that GPU view is way more useful now because you actually know. Like,
oh yes.
Yeah, when you call VKQ submit, you know it's going to submit a batch of work, and you see that in GPU view. Whereas in OpenGL, you just have random buffers being spat out at random.
Right. You know I submitted this and I can tell what was in this thing by instrumenting my application rather than I don't know. So Jeff, they've all sort of answered things that they were going to do. As a hardware vendor, what do you sort of perceive as the most important things for people to structure their application around? Like if you were saying, hey, if I were to come to you and I were saying, hey, I'm working on a renderer today, what high-level concepts should I make sure to incorporate into my renderer front end to make best use of not only Vulkan, but DX12 as well? They're fairly similar.
Yeah, I think we've touched on them. I think having a way to deal with pipeline state objects is important because that's something that was just not something you had to worry about in older APIs. I also think keeping multi-threading in mind when you're writing your code, even if you're not initially recording commands or descriptors or whatever on multiple threads, just thinking about it and not doing anything that will make it hard to take advantage of that later on is important.
Well, we've talked about pipeline state objects a little bit, and we all are aware that they're very heavy things, but maybe you could explain to folks a little bit like what a pipeline state object is and why it's a first-class thing in Vulkan.
Yeah, I mean, it's the set of shaders and all of the API state that could possibly affect shader compiles across all different hardware that supports Vulkan. That's one way of thinking about it. That's why we need to know everything at once. But the benefit of that is that that work, the application knows when that work's getting done. It can do it in a different thread if it wants to. It's a cost that's being paid once for that pipeline, whereas in OpenGL, we would get the state deltas and at draw time we would have to look at the state and figure out, and hash that or look in a cache or whatever and find the shaders to use. That cost is gone in Vulkan, and that really was one of the big sources of CPU bottlenecks in OpenGL.
I would expect that also was like one of the sort of things that the source of the problem Rolando was talking about, where I make a draw call and whoops, surprise, that one takes a bunch of milliseconds instead of, presumably it's because that was the first chance for the GL driver to go, oh, I see everything you're using with this, and actually I need to work around a problem, so I'm going to have to compile a shader.
Yeah, exactly.
Great. Let's. All right, so we talked at the beginning about benefits that we were hoping to achieve with Vulkan. Let's talk a little bit about where some of those promises have paid off, where they haven't paid off, where we think if we made some of these changes they'd pay off. And I will start. I'm going to end with you, Jeff, but I will start with Dan this time.
From a performance point of view, I'd echo some of the other comments that, for example, on Linux, on some OpenGL drivers, we're seeing better performance on Vulkan. It's helped reduce our latency, so the time from starting the beginning of a frame until the command buffers associated with it are actually submitted to the GPU is less in Vulkan, and it's in the long run, going to ease multi-platform support a lot because we use all the same rendering code on Linux and Windows.
Have we found, and I know you've only been sort of tangentially involved in this work, but for VR, have you found that it's been helpful?
Yeah, so we're bringing up VR on Vulkan in Source 2, and one of the things that maps really well to it is the ability to record a command buffer and resubmit it. So what we do is very similar to our DX11 path, but true hardware resubmission. So we record all of the commands for the left eye, and then in between submitting the left eye and the right eye, we update the constant buffer data that's pointed to by those command buffers, which is basically the transform data for the other eye, and then we can submit the second command buffer, which basically erases any CPU cost for doing recording for the other eye. So it's a nice CPU win.
So Alex Vlachos has somewhat famously over the last few years talked a lot about running start, and do you know, has running start just easier to do in Vulkan? Like I would expect it is, but I don't actually, based on the shenanigans he had to go through to get it to work in D3D11.
Actually, the person who implemented that is Pierre Lou, who's in the audience, and I don't think I
don't want to speak to it. That's fine. That's fine.
Yes.
Oh, he says yes. Okay, great. Alen, what about you? What benefits have you seen? What are the promises that haven't paid off? What are the ones that haven't paid off yet?
Well, I've talked a little bit about the performance gains, which kind of like stump us for, we haven't expected it yet because we know that we still have a lot of work to do. So it's great already. There's a big promise of stability in the frame rate. So the spikes that Ronaldo and Mikko mentioned, that previous there were spikes that were hard to explain, and even though we knew that they happened because of the reason you described, there was nothing we could do about it. There are some things about pre-warming, but it never really works as well as you would want it to. Now we still have those spikes because we still haven't implemented PSO caching in front, but this is something that now we know it's our problem and we can fix it. Previously, we were looking at it for decades, literally, and just we could only cry. So we still see a lot of potential, and everything is now on our back to be able to fix all that. The promises that haven't really kept up, I don't think that there are really any on the performance and such fields. There is these things that maybe if when we were looking at the original specs of the API itself, it looked a bit more bright and fun. There are some corner cases in the API that are clearly defined, but they were not apparent before we started implementing. So some things are a bit more complicated than we expect them to be, but nothing that would be insurmountable or that would cause things not to work in the end.
You guys, I should have asked this earlier, but you just reminded me of it. You mentioned earlier, in fact, I think all of you mentioned to some extent that memory management was sort of painful. That feels like a thing that somebody could write a layer that we could all take advantage of. Do you think that would? I mean, like I realize it would not look quite Vulkan, but do you think that would be fair?
Personally, I mean, from what we experience now that we have this, it's more about to know what to do. So it's not a big issue. Bigger is the issue about how the common buffers are actually structured in regard to primary, secondary, and rendering passes. It's hard to explain until you delve down into all of the details. But looking about what the hardware requires it and why they require it, it's like, yeah, I guess that's the only way it can be done. But it's we thought it would be easier, so some of the work takes more than we expected. But that's just how it has to be if you want to be fast on that hardware.
I see. Mikko, what about you guys? Promises?
Yeah, well, the performance was surprising to us. We were
in a bad way?
No, in a good way.
Okay, good.
So we were originally, when we were planning, okay, we're going to do this aim for experimental release for Vulkan. So we're going to aim for correctness first. That we know it's going to be slow. We just want to get it like correct first, and then we would make it fast. Then I just spent a few weeks actively like profiling and looking at the performance and optimizing things. And suddenly we were faster than the X11, and all of this happened on desktop Windows. So I got to use the Windows tools for do the profiling and all of that, and pretty much all of those improvements were direct wins on Android as well. So
great.
Usually trying to profile things on Android is fairly painful. So this was all of this pretty much directly contributed to Android as well. But there are obviously things that we don't do yet. We don't do proper sub-passes. I don't think anybody does currently. But that's going to be, I assume that would be a fairly big performance win, especially on mobiles where you use tile-based GPUs. You could potentially do things like proper deferred rendering, having a G buffer that never leaves the tile memory. So we would have
that seems like that'll be a huge win.
That should be a big thing, but that's going to require lots of changes in the upper layers of engine because we have to make it explicit that I'm now starting a subpass and this is what it's going to look like. So this is something we'll be working on, but it's going to take some time.
Okay, great. Rolando?
Yeah, pretty much what they said. Also, A lot of people on the team they want to stay in Windows 7. So they don't want to switch to Windows 10, and there's a bunch of features that are available on Windows 8.1 and because of D3D 11.1, 2, 3, and D3D 12. So now Vulkan will allow us to use all those features on Windows 7, and basically also the code for us, we only have like 2 hash defines for Android and PC. The rest of the code is just exactly the same, and like I said, you can just measure it, and it's the same performance of both. You'll see where your bottlenecks are.
Great. I guess
John,
let's.
if I can jump in. So I'm actually really excited that people aren't saying that Vulkan is too hard to use, right? You remember we were really worried about that.
That was a big
on.
concern, yes.
And people are people up here are saying there are these few challenges and you deal with them, but they're also saying I think that if you get to subtract out all of this cost of performance tuning and so many things become simpler, and I mean not to put words in their mouths, but it sounds like Vulkan is a net win in terms of productivity.
Yeah, would you guys say that that's fair?
Oh, actually, yes. Well, to be honest, the amount of boilerplate code you have to write in the beginning just to get things up and running is really quite daunting. But once you get that over that, then it's actually quite fun to program for Vulkan because we no longer have to fight against the driver, because typically we have to find a way to have the driver not try to be smart, because it usually tries to be smart and fails miserably. Not NVIDIA, I'm talking about some other vendors now.
Wave off, wave off.
Yeah. But yeah, now we pretty much are doing the things we are already doing on GLES, except that now we can be explicit about those things, like recycling buffers. We already are doing like fencing and recycling of buffers on GLES 3 because it's just faster and less buggy that way on many platforms. And now we're just doing that. Now Vulkan finally gives us the actual tools to explicitly do that.
I think it is harder. I mean, it is more verbose, and it's a little harder to use for people that haven't done any other kind of graphics work, and they just try to go in and do an app from scratch. It is a little daunting. It's it's a lot of code you have to put in, but you only do it once, and then you get used to it, pretty much.
I think that's a fair statement. I would not recommend like a college student taking Vulkan. It is not targeted at them. It is targeted at all of us, right? It is for professionals. So I want to really quickly, because we are almost out of time, I want to ask quickly if you guys have any sort of future plans that you haven't talked about with Vulkan or with Vulkan in VR. And I'm going to start with Dan, because I know we have an answer.
Oh, sure. So I forget if I mentioned it, but we're going to be demoing in the social area this afternoon and this evening SteamVR running on Linux on Vulkan with a Source 2 title on Vulkan. So please come check that out. But yeah, we're right now very focused on getting Vulkan in shape for VR, and ultimately also adding multi-GPU support to our engine for VR for Vulkan. So that's kind of where our focus is.
Great. Anyone else?
Yeah, we also, well, for us, VR, as soon as the platforms and the API and the SDK is basically supported, we'll just jump in, since we're almost done with the Cherry Model 5 feature set.
Great. So we probably don't actually have time for questions, but however, if you have questions, we will be right outside for a little bit, and then we'll be around all the rest of the day, and you can feel free to grab us, any of us at any point, and maybe we'll all go drink some cough medicine together. It'll be a really, so we'll give you really honest answers, maybe more than you wanted. Thank you all so much for attending. Thank you guys all so much for participating. We hope this was helpful.